Okay, today we're going to talk about the third type of graph, or third type of conic that we are graphing. We talked about circles, and then we talked about ellipses, which are like circles, but they're stretched to either a major X or major Y, right? Today we're going to talk about hyperbolas, which look very similar to the equations look very similar to ellipses, except that their graphs are different. Hyperbola could be major X, like this, or it could be major Y, which is kind of like that. Okay, so I'm going to show you how that works. It's not too hard, but as long as you see the steps, you could do just fine at this. Let me pull up the next slide here. Okay, so here are the steps. Identify the center just like normal H and K. Identify which form it is. There's two forms here, and I want you to just ask yourself right now, what's different about this equation and the equation of an ellipse? Raise your hand when you have an answer. What's different here? Not quite.
The H and the A switch. Like on the first one, the H on the left side.
But they can switch, right? H and K switch. I guess A and B do switch, but H and K do switch, but they don't really switch. Why don't they switch? Where are they still next to?
The X and Y.
They're still next to the X and Y respectively, right? H is always going to be next to your X. K is always going to be next to your Y, you see? K, K, H, H. What else is different? One super important thing. Yeah.
Graph it like one's going to be on the positive, one could be on negative.
Nope. I'm just talking about, yep. What was it? The minus sign. You all see the minus sign here? Circles, we had a plus sign here and here, right? Ellipses, we had a plus sign. Over here, we have a minus sign. Okay, so that's the difference. So your A is always, remember ellipses, A is always the bigger number. Remember that? So here it's always the bigger number also, because A is always positive, right? Over here we have a positive term here. Excuse me. A, we have a positive term here because it's on the left. A squared on the bottom here is also positive. The smaller number is always negative, right? So you have the B squared. So that's how you know the difference, but you need to memorize these forms to be able to recognize them. This one's very similar to ellipses, except for the major thing I want you to notice is what Yusuf said is that there's minus signs here, okay? So the other thing I want you to write down in your notes next to these steps are the following. I want you to write down the forms. So your major X will look like this, where one graph will look like two separate graphs, but it goes left and right, opens left and right. Major Y opens up and down. So take a moment to write that down, and then I'll start teaching you how to do these. Continuing on here. Okay, I'm going to show you how to do two of these. These graphs I need you to pay attention to. If you just follow the steps, you'll be totally fine to do this, okay? So the first thing I want to do is figure out, is it a major X or major Y hyperbola? So we're always looking for the positive term, which is the X term. So I know it's going to be major X. Okay, and since it's major X, it's going to open left and right, okay? So I'm going to draw like a little picture just so I know it opens left and right, okay? And then since it's major X, I need to figure out, well, either way, I still have to figure out what the center is. Our H, there is no H by the X, so I could assume it's 0, and our K is 1. So just like before, you would just do your H and K, 0 and 1. And then we know that it's major X, so the positive term has to have the A squared term underneath it. So I take the square root of 25, which is A would be equal to 5. And then the B is the 9, the square root of 9, so square root of 9 is 3. Okay? So that's the information I need to find just by looking at the equation. Now I would graph on my graph paper the center. I go to 0, 1, plot a point. Okay? I went too fast there. All right, now I need to think, is it major X or major Y? This is super important because major X would tell me where I need to put A. So I'm going to count 5 to the right of my center and plot a point there, and 5 to the left from my center and plot a point there. Okay, so I got 5 and 5 here. Then I do my B. I'm going to go up 3 and down 3 from my center. Okay, so now I got a point here. Okay, so usually at this point when we did ellipses, you would just draw your ellipse, right? So now we have to do some extra work to do a hyperbola. So watch carefully. Now we're going to draw a box with a dotted line, okay? So I'm going to draw a dotted line around this whole section here, okay? what we're going to do right now is set up how we draw our graphs. Then I'm going to draw two diagonal lines, one going diagonal in both directions. Okay, and I'm doing this all dotted because this isn't the graph, by the way. This is not the graph. This will help us guide our pencils to draw the graph correctly. I knew that this was major X, so I'm going to start from this point here and draw a curve that's close to these lines but never touching them. Because this is a vertex, and the other point's a vertex too. So I'm going to draw a graph going that way and down going the other way. Same thing on the left and right. I'm using a solid line to draw the graph, okay? Because this is really what the graph is. All this other dotted lines, all these other dotted lines are just there to help us draw the graph. Okay, but if I were to graph this on Desmos, all that Desmos is going to create is this graph on both the left and right side of the center, okay? This line right here that goes diagonally, this is called an asymptote, okay? And I remember talking about this about a month ago, what an asymptote is. An asymptote is a line that a graph gets close to but never touches, okay? That's what an asymptote is. So this line's an asymptote and that line's an asymptote. So today what we need to know how to do is draw the graph, identify both of the vertices, and identify what an asymptote is. Okay, so that's number one. Number two, I'll do this one more time. Number two, we got y plus 2 squared over 9 minus x squared over 4 is equal to 1. So first thing I want to figure out, is it a major x or major y? Since the y term is positive, I know it's a major y. Therefore, I'm going to write that down. And I'm just going to draw a little picture just to remind myself major y opens up and down. Okay? Then I want to figure out my center. On my center, I have to be really careful now because h and k are in different places, right? H is always next to the x term. K is always next to the y term. So is there any number next to the x term? No. So we assume our h is 0 and our k is negative 2. Okay, that's super important because you might say the center is negative 2, 0, and that would be wrong. Is my center negative 2, 0? No, it's 0, negative 2. Totally different point, okay? Then we figure out a and b. A is always underneath the positive term, so in this case it's the square root of 9, which is going to be 3. And then b is next to underneath the negative term, which is 2, okay? So I'm going to plot my center point now, 0, negative 2. 0, negative 2 should be right there. Okay? And I know that it's going to open up and down, so my A is not going to be plotted left and right this time. It's going to be plotted up and down. So I'm going to go up 3, plot a point, down 3, plot a point with my A. And then I'm going to plot a point going left and right with 2. Then I'm going to draw a dotted line representing this box. Then I'm going to draw a diagonal line representing the two asymptotes. So looking at the original problem, I know is major y. I wrote a note down, so I know it's going to open up and open down. So I'm going to go to these two vertices and draw a graph that opens down with arrows and opening up with arrows. Both of these lines need to be curvy, and they need to but get close to these asymptotes, because that's what they are, okay? And that's it. That's how we do today's lesson. Okay, I know this is foreign. You've never seen this before. It looks like a parabola or a quadratic equation, but it's not the same thing. This is different. Okay, so what I'd like you to do right now is you're going to do three things. Ones will tell the twos. How do we do number one? Explain everything. Major X, center 5, and 3. Explain how I graphed it. Explain why it's dotted lines and not solid lines here, and why we use a solid line here. And then twos will do the same thing. That's the second thing you're doing. And then the third thing you're doing is writing this down. I'm going to give you about 3 minutes to do all of that, okay? Ready, set, go. Okay, number 3. Please write down number 3 in your notes, and then you'll graph on your Doceri apps, okay? Or on your papers if you really want to just do that. Okay, now this graph, look at number 3. This graph, if there was a plus sign in the middle, this would be a circle, okay? But since there's a minus sign, this is not a circle anymore. This is a hyperbola, okay? So just so you know that. It would have been a circle if we would have just put a plus sign here, and we would have multiplied everything by 16, so it would have been 16 here, and we would have had like 1, or these denominators would have disappeared, okay? That would be a circle, but the only difference is, again, the minus sign here, okay? So Okay, first thing we need to identify is it major X or major Y? Turn to your neighbors and tell them, what do you think, major X or major Y? What is it, everyone? Major X, okay. So, and I like drawing a little bit of a, mini graph so I remember it opens left and right. Especially when I'm trying to learn something, I try to just draw doodles so I remember. Okay. Then we have to find the center. What's your center? 0, 0, good. Okay, looking at the term underneath the X term, what's your A? A is equal to? Good. B is equal to? 4, okay. So this is all the information we need. Now we can start graphing. So you can pull out your iPads or work on your notes, okay? So take a moment to do that. All right, so we're going to go to 0, 0, the origin of the graph. We're plotting a point for the center, okay? And we know it's major X, so since the center is at 0, 0, we're going to go left and right, 4 in each direction and draw a point. And then we're going to do go up and down 4 in each direction. Now remember circles, right? Doesn't this look like it could be a circle if we just started drawing it? Remember doing that? But is this a circle? Yes or no?
No.
No. Okay. So, next step. Turn to your neighbor, tell them what you would do next after you plotted these 4 points. Okay, what do we do? Good, we're going to make a dotted box, okay? Why dotted? Because it's not really there. Good. So why are we even drawing it if it's not really there?
It helps graph.
Yep. It's a guideline, helps us graph. Good. Thank you. Next, tell your neighbor what you would do. And to use the correct verbiage. Draw those what? Draw the
Lines, arrow, I don't know.
what are they called?
Asymptote.
Good, asymptotes. We're drawing these two diagonal lines which are the asymptotes. What does asymptote mean?
Lines that don't touch.
Touch what?
These. You draw another line, but it will never touch.
Okay, so it's the lines that the graph gets closer and closer to but never touch. An asymptote is a line that the graph gets closer and closer to but never touches. One last time. An asymptote is a line that a graph gets closer and closer to but never touches. Turn to your neighbor, tell them what an asymptote is. Okay. Alright, so you should have this. This is all a guideline, right? It doesn't really exist. Now we're going to graph it, okay? So we know it's major X, so we want to start on these vertices, not the up and down vertices, but these vertices, okay? So we're going to go drawing a nice wide graph because this asymptote starts all the way over here, so we're going to make sure we get to it. And also there, okay? So yours should look like mine. I'm going to come around in about 30 seconds. Check your work. Make sure you copied or una más. That means one more in Spanish. See, I teach you more than just math. Okay. Number 6. Here we go. So I'm going to just ask you to write that down. X plus 1 squared over 10 minus y plus 1 squared over 15. Why did I have you do this one? Why is this one special? What's the difference? Good. What's not a perfect square? A squared and b squared, are they perfect squares? No, they're not. So let's get started on this. Let's figure out just go through the steps. We have to figure out this major X or major Y. So is this major X or major Y, everyone? Major X. Okay. What's the center? -1, -1. Okay. What's your A?
Rad 10.
Rad 10. Good. Now rad 10, can I simplify rad 10 at all? No, it's irrational. And if I were to put that in the calculator, I'd probably get some decimal, right? But couldn't we estimate it?
Around 3.2.
Yeah, it's around 3.1, 3.2, right? So we're not going to write the whole decimal out because it's irrational. It goes on forever, and we can't write every decimal that's possible. So this encapsulates the whole number, rad 10. Okay, what's your B?
Rad 15.
Good, rad 15. Okay. Rad 15, can we simplify rad 15?
No.
No, we can't. So, rad 15, we could estimate though. What's rad 15 almost?
Around 3.8.
3.8, 3.9, okay? So, go. I want you to finish this one off. And then I'll come around and check your work in about a minute, okay?